In this video, we'll discuss polyhedra and other solids. Now, a polyhedron is a closed three-dimensional shape where the outer surfaces are all polygons. This constructs faces, edges, and vertices on the polyhedron. The faces are all those polygons that create that outer surface, whereas the edges are where two faces come together, and the vertices are where multiple faces will come together. So if we look at these three solids, we want to determine, is it a polyhedron? If I look at my first solid, it is constructed using all rectangles. So yes, that is a polyhedron. And if I count it, I could see that there are 6 faces, the front, the back, the left, right, the top, and the bottom. There are 12 edges, so that's each of the segments going in between. And then there's 8 vertices, which are the red points that are shown up in this image. If I look at my second solid here, it's constructed using triangles. So yes, this is a polyhedron. And in this shape, there are 4 triangles, so there's 4 faces, there's 6 segments or edges, and there's 4 vertices. And in my third solid, this is a cylinder, and that's made up of having a circle. And a circle is not a polygon. Therefore, this is not a polyhedron. Now, one of the types of polyhedron that we talk about is called the prism. And this is a polyhedron where the bases are similar and parallel to one another. The base is always the polygon that forms the ends of the prism. It does not mean the top and the bottom. That's important to recognize. So when I look at each of these polyhedron, I want to look at what is the shape that's being pulled through that's parallel to one another. Now the first one, I could use different sides because of how it's constructed. This is a rectangle on the front to the back. So this would be called a rectangular prism. I could have went left to right because those are rectangles as well, and top to bottom, and that's rectangles as well. So the rectangular prism actually has different ways it could be considered a rectangular prism. Now when I look at my next solid, and this is a polygon or polyhedron, I want to say what's the shape that pulls through to make the two parallel polygons. And in this case, I have a triangle on the front and a triangle on the back. And I can see that as I follow that, it's following the entire solid. So this is a triangular prism. And when I look at my third one, if I notice, I've got a pentagon on the top, and if I drop it straight down, it forms the pentagon on the other side, and I stay all within that prism. So this is a pentagonal prism. Now, as I mentioned earlier, cylinders use circles for that solid that's parallel to one another. They can be congruent or similar. So when we think about different types of cylinders, we think, where is the base? And say, does that pull through the entire shape? In this case, yes. If I look at the second one, the cylinder is going from left to right. If I look at the third one, yes, it's not at a right angle. It's got that skewness to it. It's called oblique. But if I follow that cylinder, the circle will pull through the entire solid. And in the third example here, they are not congruent circles. They are similar circles that go from a larger one on the bottom to a smaller one on the top, but that is still a form of a cylinder. Now, cones and pyramids are taking the same idea. It's just a matter of where each of them meet at an apex. The pyramid starts with a polygon as its base that meet at, and then the faces meet at an apex, whereas a cone is a solid that has a curved base that tapers to a specific point, not on the base. It reaches its own apex based on that curve. So when I think about my different pyramids and cones here, if I look at my first one, I'm starting with a triangular base in this case, and when it's drawn up to the apex, you can see that's following that triangular shape. So this is a triangular pyramid. My second example, I'm starting with a base of a pentagon, and I've got triangles for all the other sides, and I can watch that and see that if I draw it up to the apex, it's following that pentagonal shape the entire time. So this is a pentagonal pyramid. And in my third one, I can see that the base here is a circle that then tapers to a given point off of that circle. So this would be a cone. Now, last thing we'll talk about is the right and oblique solids. To be right for a prism or cylinder means that the faces are perpendicular to the bases, Whereas with a pyramid or cone, we know the apex is directly above the center of that base. It's going to be at a 90-degree angle. And oblique means any other case where the solid does not have those right angles. So if I look at these four solids, my first one, I have a rectangular prism. And on top of that, if I look at the faces that are connecting my bases, they are perpendicular to the bases. So this is a right rectangular prism. In the second example, it is a cylinder, but I can see that it is skewed. That skewness means that we call that oblique in a solid. So this is oblique cylinder. If I look at my third example, the cone, I can see that that apex of the cone is at the dead center of the cone. So this is a right cone. And then in my fourth example, it is a pyramid. But if I think about where's the center, I can see that the apex is off center. So therefore, this is an oblique, and this could be a square pyramid.